Welcome back to my math class, and we are still in the topic of factoring polynomials. Specifically, you will learn today on how to factor difference of two squares and how to factor sum and difference of two cubes. But for this tutorial video, you will just learn on how to factor difference of two square. So check out my another video for factoring sum and difference of two cubes. Let's start. First, we need to remember how to square a number and finding the principal root of a given number or expressions. So for example, what is the square of 2? So this is equal to 4. How about the square of 5? It is equal to 25. So how did we get 25? It is not 5, the base 5, times the exponent 2. Okay? So the exponent tells on how many the base will be multiplied by itself. And that is 2 times. Therefore, for the solution, it is 5 times 5. That's why we have 25. Another example, what is the square of 7? For the solutions, this is 7 times 7. And this is equal to 49. So I hope you remember now on how to square a number. This time, finding the principal root or square root. Okay? So for example, what is the square root of 4? Think of a number whose squared is equal to 4, and that is 2. Another, what is the square root of 9? This is equal to 3. Another, what is the square root of x squared? This is equal to x. Very good. And then, last example, what is the square root of y squared? This is equal to y. Okay, I hope you're ready now for our topic for today, which is factoring difference of two squares. So I have here 8 polynomial expressions, and we're going to identify if factoring difference of two squares is applicable for each expressions. So we need to understand the title of our topic for today. So first, it says that the polynomials, the operation for the polynomial must be in subtractions. It says here, difference. So we'll eliminate the polynomial that does not use subtraction. So letter A, it is x plus y. It uses addition. Yes. So we'll eliminate it. So factoring difference of two squares does not apply in this polynomial. For letter B, m squared minus 4. Okay, so it uses subtraction. For letter C, n squared minus 5. Subtraction. Okay, let's check it. And then, c squared plus d squared. It uses addition. So, we'll eliminate it. For letter E, x squared plus x minus 1. We'll eliminate it because it uses addition. Then for letter F, y squared plus 9. Eliminate. For letter G, k squared minus 1. Okay, let's check it. For H, 9x squared minus 4y squared. It applies. For I, p raised to 4 minus p squared minus 3. All of the operation is subtraction. So let's check. And then, h squared minus r squared. Check. 4a squared minus b squared. Check. M raised to 6 minus n raised to 4. Check. Okay. So, we eliminate 4 polynomials. Letter A, letter D, letter E, and letter F. Okay. Now, the expressions must be, or each term must be in 2 squares. Now, the expressions before and after the subtraction sign must be in squares, or it has a square root. And so let's check. For letter B, m squared minus 4. Is m squared has a square root? Yes, it has. How about 4? Yes, it has. And for letter C, n squared minus 5. N squared, does it have square root? Yes. How about 5? Does it have square root? No, so we'll eliminate it. For letter G, k squared minus 1. K squared, does it have square root? Yes, it has. For 1, does it have square root? Yes. So let's check. We now have 2 polynomials that can be factored as a difference of 2 squares. And then for letter H, 9x squared. Yes, it has square root. 4y squared. It has square root. For letter H, it says 2 squares, but look at each term. It has 3 terms. So, factoring difference of 2 squares that must apply to this expression. For letter J, h squared minus r squared. H squared, yes, it has square root. R squared, yes, it has square root. For letter K, 4a squared minus b squared. 4a squared, yes, it has. B squared, yes, it has. Let's check. And for letter H, m raised to 6 minus n raised to 4. M raised to 6, yes, it has square root. And for n raised to 4, yes, it has a square root. Therefore, we have 1, 2, 3, 4, 5, 6. 6 polynomials that can be factored as a difference of 2 squares. Now, let us factor these polynomials. Okay, so for the pattern of factoring difference of 2 squares is x, it is the product of x minus 1 and x plus y. Meaning, the factored form of difference of 2 squares is a sum and difference of 2 terms. So for my first example, which is from our activity a while ago, letter B. So let's factor m squared minus 4. M squared minus 4. For the solutions, we need to find the square root of m squared and the square root of 4. So the square root of m squared is equal to m. And the square root of 4 is equal to 2. Therefore, our two terms are m and 2. Now, for the final answer, the factored form of m squared minus 4 is the sum and difference of m and 2. And this is now our final answer. Another example. What is the factored form of k squared minus 1? Now, for the solutions, we need to find the square root of k squared and the square root of 1. And the square root of k squared is k. And the square root of 1 is 1. Now, our two terms are k and 1. Therefore, the factored form of k squared minus 1 is the sum and difference of k and 1. This is now our final answer. Another example. H squared minus r squared. For the solutions, the square root of h squared is equal to h. And the square root of r squared is equal to r. Therefore, our two terms are h and r. For the final answer, the factored form of h squared minus r squared is equal to the sum and difference of h and r. Another example. 4a squared minus b squared. So, for the solutions, find the square root of 4a squared, which is equal to 2a. The square root of 4 is 2, and the square root of a squared is a. Now, for the square root of b squared, it is equal to b. Therefore, our two terms are 2a and b. And for the final answer, the factored form of 4a squared minus b squared is the sum and difference of 2a and b. 2a and b. So, this is our final answer. Another example. What is the factored form of 9x squared minus 4y squared? For the solutions, the square root of 9x squared is equal to 3x. Because the square root of 9 is 3, while the square root of x squared is x. And the square root of 4y squared is equal to 2y. The square root of 4 is 2, and the square root of y squared is y. Now, the factored form of 9x squared minus 4y squared is the sum and difference of 3x and 2y. another example, which is my last example. M raised to 6 minus n raised to 4. Look at the exponent. It is greater than 2. So, how to find the square root or principal root of these expressions? For the solutions, the square root of m raised to 6 is equal to m cubed. So, how do I get m cubed? So, think of a number or expression rather whose squared is equal to m raised to 6. And that is m cubed. Okay, for further solution, m cubed squared. And if we rewrite it into expanded form, it is equal to m cubed times m cubed. And by laws of exponents, when we multiply variables, same variable, we will just add the exponent. So, 3 plus 3 is equal to 6. That's why, when we reverse the process, the square root of m raised to 6 is equal to m cubed. Now, for the second term, n raised to 4. The square root of n raised to 4 is equal to n squared. Okay. Now, our two terms are m cubed and n squared. So, for the final answer, the factored form of m raised to 6 minus n raised to 4 is equal to the sum and difference of m cubed and n squared. And this is our final answer. And this is the process of factoring difference of two squares. So I hope you now know how to factor difference of two squares. Okay? So for your assignment, do activity 2 in your enrichment activity entitled Factoring the Difference of Two Squares. Turn in your answer sheets in our Google Classroom. Thank you, and that's all for factoring difference of two squares. So check out my another video for the factoring sum and difference of two cubes. Goodbye.